Hello, my name is Maxwell Warsaw, and this is my presentation on Lab 6 register files. Table of contents. First, there's an introduction, then there's an overview of register files, then there's a look at each individual component of a register file, there's a look at my final circuit, and then there's a conclusion. Introduction. Thesis. A common requirement for computer processors is access to stored information. A register file is one implementation of a way to store and access information in a processor. In this lab, we were tasked with implementing a register file in Logisim. The goal was to become familiar with D-type flip-flops, multiplexers, and decoders. Register file overview. A register file is one type of memory circuit used by processors to store multiple n-bit long words. They can be used in many ways inside of a processor, including program counters, address register, and to hold data being processed by the processor. An example of a real-world use of a register file is static RAM. Register file parts. A register file is comprised of three different parts: a write decoder, the registers, and a multiplexer. Write decoder. A decoder takes in several input pins and selects between 2 to the n outputs, where n is the number of input pins. A write decoder is a decoder with an enable pin. When enable is 0, there is no output. When it is 1, the output of the decoder is passed. Illustrated here is my write decoder circuit. Registers. A register is comprised of a clocked D-type flip-flop and a multiplexer. The multiplexer selects between the data out pin on the D-type flip-flop and the data in pin. Above is an example of a 1-bit register, and below is my 4-bit register circuit. Multiplexer. A multiplexer will output one of multiple different inputs. The multiplexer I designed for my register file has 8 4-bit inputs and 3 select lines, with 1 4-bit output. This is my final circuit. It is comprised of 1 write decoder, 8 4-bit registers, and 1 multiplexer. Pins A0 through 2 select which register to read from and write to using the decoder and multiplexer. Pins in 0 through 3 are the data in pins. Pin WE is the write enable pin, and each register shares one common clock. That's the clock input pin. Conclusion. Register files are made up of 3 different parts: write decoder, registers, and a multiplexer. This lab was successful in teaching how register files work, as well as making me more familiar with all of the individual components of a register file.